6.5 Trapezoids and Kites. By the end of this lesson, students should be able to identify and apply properties of trapezoids and identify and apply properties of kites. To begin, we first need to understand what a trapezoid and a kite are. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So our trapezoid is going to be different than the parallelograms that we've been talking about because it only has one pair of parallel sides and it's not part of the parallelogram family. A kite is a quadrilateral with two pairs of consecutive congruent sides, and a kite is not part of the parallelogram family either, nor is it part of the trapezoid family. We have several theorems that have to do with trapezoids and kites, but first we need to understand the different parts of the trapezoid. A trapezoid has a pair of parallel sides, and these parallel sides are called bases. The non-parallel sides of a parallelogram are called the legs. If a trapezoid is isosceles, meaning it has congruent legs, then we can say each pair of base angles is congruent. And our base angles are going to be the ones that are at the ends of the base. So the vertices that are the endpoints of a base, the base angles that correspond with it are going to be the angles that have the same vertex. And so DC is our other base, and then the base angles D and C are going to be congruent. And this is only true if you have an isosceles trapezoid. The converse of this is also true. So if you see that you have a pair of base angles that are congruent, then we can say that the trapezoid that we're looking at is in fact an isosceles trapezoid. If we have an isosceles trapezoid, we can also say that the diagonals are going to be congruent. So there are really three main ideas that we have with trapezoids, but they all deal with isosceles trapezoids. So let's practice some of these properties we just learned about. If we have a trapezoid WXYZ and we know that it's isosceles, meaning that its legs are congruent, then we need to find the measures for angle X, Y, and Z. Well, we know that if this is 110, then the other base angle has to be 110 degrees. So angle X is also going to be 110 degrees. Now, we don't know what the other base angles are, but we do know that they're going to be congruent. So we can set up an equation in order to solve. We know that 110 plus 110 plus, let's just call this, we'll call this variable P. So plus 2P is going to be equal to, all quadrilaterals have to have a sum of 360 degrees. So if we simplify this, we can say that this is 220 plus 2p is going to be equal to 360. And if we subtract 220 from both sides, we get 2p will be equal to 140 degrees, which means that p is equal to 70. So we can say that the remaining two base angles have to each be 70 degrees. So the measurement of X is 110, the measurement of Y and Z are both 70 degrees each. There is one other important observation we should make from this, and we have a pair of parallel sides. And we can say that one of the legs can serve as a transversal. And we know that when we have consecutive interior angles, those will always be supplementary. And so in our trapezoid, since we have a pair of parallel sides, we will always have those one angle from one base and another angle from another base should be supplementary to one another. So instead of setting up an equation saying it all equals 360, we could have just said that 110 plus p is going to be equal to 180 and gotten our measure that way as well. One more theorem, and this has to do with the mid-segment of a trapezoid. And this is going to be true for any trapezoid, not only for isosceles trapezoids. And the theorem says that the mid-segment of a trapezoid is equal to 1/2 the sum of the bases. Well, our mid-segment is going to be kind of like our mid-segment of our triangle, where it's going to be connected by its endpoints are going to be the midpoints of each side. Now, to say that it's 1/2 the sum of the bases, let's see this in action. So here we have a practice problem, and we are told that this top base is 12, the other base is 16, and we need to find out what x is equal to. Well, x is our mid-segment, and we can see that because its endpoints are the midpoints of the legs of your trapezoid. So the way that we're going to find out our mid-segment is we know that it's going to be 1/2 of the sum of the bases. So I can take my bases, and I'll have to find my sum of my bases, and then we will have to take half of that, or in other words, divide by 2. So we know that the sum of the bases is 28, and so our mid-segment length, which is x, is going to have to be equal to 14. And this is true for any time you see a mid-segment of a trapezoid. We've talked a lot about trapezoids, and now it's time to find out a little bit more about kites. And there are two theorems that have to deal with kites. One is that if a quadrilateral is a kite, then you can say that the diagonals are going to be perpendicular. So the diagonals of a kite are perpendicular. Our other theorem says that if we have a kite, then exactly one pair of opposite angles are going to be congruent. And that one pair of opposite angles that are going to be congruent is going to be, in this diagram, angle C and angle A. The way that you know that it's the pair of angles that's going to be congruent is one of the sides should be coming from one pair of congruent sides, and then the other side of the angle should be coming from the other pair of congruent sides. So if we look at our diagram, we know that BC and BA each have 1 tick mark, and CD and DA each have 2 tick marks. And the angle formed by one of each of these pairs is going to result in the pair of congruent angles that we have in a kite. And we can practice this theorem as well. And here it's asking us to find the measures for x and for z. Well, noticing that angles x and z are formed by one pair of the congruent sides as well as the other pair, we know that these angles have to be congruent. So we can end up setting up an equation to solve for this, because we know that all the angles, interior angles in a quadrilateral, have to add up to 360. So we'll say that 97 plus 139 plus, well, we'll just call this x this time, and since they're congruent, we can say plus 2x. They will all have to have a sum of 360 degrees. When we simplify this, we're going to find that we get 236 plus 2x is equal to 360 degrees. And when we subtract 236 from each side, we get that 2x will be equal to 124, which means that each value of x will be equal to 62. So when it's asking us to find the measure of x and z, we know that each x and z is going to have to be equal to 62 degrees. Well, we already have a lot of properties that have to do with quadrilaterals and different types of quadrilaterals, and we just learned a few more. And this is where we're going to stop for today. And since that's it, it's time for our joke. And our joke for today is, why did the elf put his bed in the fireplace? Well, because he wanted to sleep like a log.